Greetings, Earthlings. Well, we've seen in previous video my restoration of this Fluke meter, so I thought we would, even though it probably doesn't need it, we would run it through the calibration procedures. Have the manual here. Manual, there it is. Okay. And it's got a whole section on calibration procedures. It has some checks that you run it through, and I'm not really going to run through the checks because we're going to sort of calibrate it regardless, even though, again, it's probably pretty close. Now, one thing the manual does say is that to conduct calibration at an ambient temperature of 23 plus or minus 5 degrees Celsius. So let's check. So that's between 18 and 28 degrees Celsius. We've got 18.5 here. And, oh yeah, okay, what equipment are we going to use? Yikes, look at all this stuff. I got my standard resistor here, my 100 ohm resistor. I've got this box that we'll get to. I've got a DC power supply. I've got a current source that I built, and I've got an AC signal generator. I don't have, of course, the proper test calibrator from Fluke, which is, I forget what it is. It doesn't matter because I don't have it. So I'm going to have to make do. And so I'll have to modify the procedures a little bit because it says, set the calibrator to 1.9000 volts. Well, I can't really do that. So what I'm going to do, I have this Tektronix DMM4020, which I'm going to use as the reference. We're going to assume that's correct, even though it's never been calibrated. And I forget how old it is, but it's over 5 years old. So it's probably due for a calibration, probably, definitely. But what we can do is measure something with that and then compare that with this and make them agree, at least. That'll be less confusion. Oh, yeah, brilliant. If my power strip doesn't flake out on me. All right, I'm going to do this. And while we're waiting for that to get back, let me talk about this box. This is a box I built. And what I have in it here is a 4.096 volt reference. That's a Maxim. Oh, I forgot to write down the number of the chip. It's a Maxim chip, a voltage reference, and it's 0.02% accurate. 150 volts DC. That's just generated with a step-down transformer, or a step-down transformer to generate 12 volts for this. Oh, and by the way, I have 10 megahertz oven-controlled crystal oscillator over here, which we won't be using for this test, but that runs off of 12 volts. This voltage reference runs off of 12 volts. So I have a step-down transformer to run that power supply. It's a linear power supply. And then I have a step-up transformer, then rectify that and go, I have a Zener diode or Zener, depending on where you're from. Zener diode, and then a little pass transistor just to try to isolate that diode from the load. Although the load that these things put on it, these have minimum 1 megohm input impedance, but it can still affect it. Down here I have some high precision resistors. This one is actually not populated, and then I have space here. So there's 10K, 100K, 1 meg. I have space for a 1K and a 10 meg, but I don't have them yet. I don't even have the 100K yet, but that will be the next one I get, I guess. So here's a 100K resistor. We'll use that. 10K 0.005%, 1 meg 0.05%. And this is a 1% right here, you know, with probably a horrible temperature coefficient. Okay, so calibration adjustments. Procedure. We start with DC calibration, and we're going to have to open that thing up. So let me go ahead and... That's how easy that is. Set that aside. Now, it'll have to be upside down because the adjustments are here on the bottom. Well, that makes it a little weird, but hopefully you'll still be able to see the... Yeah, I think you can see the display. Okay, but it's upside down. Oh, okay. Well, just for quick reference, we'll do the 4096 test just to see how close we are. 4096.34. This says 4097. That's pretty close. Plus or minus 1 count, yeah, you're probably in spec there. But let's look. I'm going to need that power supply. I think I'll move it over here. Okay, and we start on the DC volt scale. What I have is this power supply here, which you don't need to see the readings on that because we're going to go by what this says and just try to match those. We start on the 2 volt range here, and we want to put 1.9 volts out, approximately. So there we go, 1.90501. That's pretty good. Whoops. I'm on the 200 millivolt range. There's the 2 volt range. Okay, 1.9062. Well, that's not good enough, if you ask me. So we adjust R11. This is R11 here. Okay, I've got 50, 51. That rounds off to 50. We call that good for now. Next step is, it says minus 19 volts, but it really means minus 1.9. So let's just reverse these and check it. Okay. 1.9, minus 1.905. Good. Okay. Now we go to the 200 millivolt scale. So I am going to switch over here. And I'm going to crank this down to 1. Yeah, 190 millivolts, that's pretty good. All right, 190.5. 190. Oh, I'm on minus still. Let me switch that back. Okay. All right, 190.50, 190.46. That needs to come up a bit. That is R12. It's right next to R11. Okay, 190.49, 49. Whoops. What have I done? So let's settle down. 147, 49, 45. bouncing around here. 190.5. 5.1. Well, I'm going to call that close enough. You didn't see I headed it out. Obviously, a whole bunch of tweaking. It's within 2 counts, which I'd say is probably close enough. For now, we may come back to that. Now it wants 200 volts DC. Well, I don't have 200 volts DC. Well, it wants 190 on the 200 volt scale. But again, I have this 150 volt. Okay, so I'm going to switch to 200. Scale. And we'll plug it in here. See how those test points are just the right size to take a probe. Okay. 14988, 1498788. I'm going to call that good. Okay, and then the next would be 1,000 volts. There's no way I can do 1,000 volts, so we'll just leave that alone. Assume that's correct. All right, and for AC, you can see I've moved the camera a little bit. I'm going to use this generator and just do the best we can with this. So we're setting it to AC volts. We're starting on the 2 volt range. So I think we're on the 2 volt range there. I don't know what this is currently set at. And it wants 1.9 volts RMS at 100 hertz. So I'm going to turn that down to approximately 100 hertz. I'm going to times 10 scale there. AC volts. It's 101 millivolts. Probably want more than that. I want 1.9. Okay, that's good. 1.909. 1.9095. 1.90, let's see, 88. That says 94. It's off by about 5 counts. This is R7. All right. 7.6, 7.8. I don't think I'm going to get any closer than that. That one, it turns out R7 and R29, which R29 is the next one, are interacting adjustments. Repeat until both are within their limits. Okay. Oh, and that's plus or minus 5 counts is what it should be to consider it in spec here. And so we're definitely within that relative to this. Okay, so now we go down to 100 millivolts RMS. So I'm going to switch over to here. I think this will get me 100-ish millivolts. All right. And that's on the 2 volt range, yeah. Yeah, and so that one is off. 100, I've got 3 zeros. It says 1018. So this is R29. This guy. Oh, 5. 100. No, I want 10001 is where this should be. Right around there. Yeah. Let's go back. That's within 1 count. And that's within 2 counts. I'm calling that good enough. Okay. 2 volt with no output. Says less than 40 counts. What do you got? 8. Up here we got 14. Okay. I'm calling that good. Okay, on the 20 volt scale. Now we go to the 20 volt scale. Okay, back to this thing. And at 100 hertz, approximately, we want to give it 19 volts. I don't think I've got 19 volts. Let's see what I can get. That's the best I can do. Okay, 10.815, 10.809. Okay, this is weird. Okay, so the this is adjusting the range. There's capacitors here, and you check it at 100 hertz and at 10 kilohertz, and they're supposed to be within 2 counts of each other. So I don't know. This says 10.8136, 10.8008. It's off by a little bit compared to that, but going from 100 to 10K, we go 10.844. Now I'm assuming right now that this is the output of this is constant. We'll verify that up here. Okay. 10.807. This is at 100 hertz, approximately. Okay, 10.8125. 10.82. So that went up. Now went to 10.843. Well, I don't know what to do with this one. So I'm going to leave it. I'm going to leave it alone. All right. Well, next is resistance. So we'll shut this off. Oh, current. Where was current? We can at least verify the current. Okay, so we're set up to measure the current now. Set it to 200 microgram scale where we've swapped the leads over to where we're measuring current. And now if I flip that on, okay, 199. Well, I can do better than that. Whoa, that's like way off compared to the reading. What? We seem to have a slight disagreement between the readout on the instrument. This is like that power supply. Of course, I built this myself, so I don't trust it. Anyway, these should match. 186.2 something, 186.2. Yeah, okay. Call that good. Let's go to the 2 milliamp scale. And let's see. Oops. What about 1.9? Again, it's bouncing around, but 1.8, you know, I want a 0 in there, just for, all right, 1.803, 1.8026, 27, close enough. Okay, 20 milliamp scale, can I go to 20? I don't know. The 20 milliamp scale, crank this puppy up. Oh yeah, I can go to 20. Ah. 19.07, 19.08. Pretty close. You know, I don't need this level of precision. Is it 19.07 or 19.08 milliamps? What difference? Go to 200. And I'm going to max this out because I only go up to around 100. 104.107. 106. This is saying 89. That's brilliant. There, that's at max. 109 is bouncing, 0.3, 109.3, 109. Yeah, close enough. Okay, so next is resistance. And for that, let's start with the 10 ohm. Well, no, because it has resistance test. Okay, first of all, short the leads together, right? There is one adjustment on resistance, and that's on the 200 ohm range. I see 0.2, about 0.2 in both leads. Okay. This is the Tektronix. This is 100 ohms. And no, I'm not going to do 4-wire. Okay, 100.04. And that's, of course, because here, we'll do a relative reading. 99.942. Okay. 99.942. And we'll take this guy. I've got 0.2. I can do a relative reading here. Okay. 99.942. 99.93. Okay, that's pretty close. I think we're in agreement there. This is 10K. I'm going to take off relative. Okay. I'll take off relative over here, too. Okay. That's supposed to be 10K, plus or minus 0.005%. Is this 005? Because if it is, it's just barely in spec. Well, we don't know, again, how accurate this thing is. Okay, 99.95. There is 99.98. There is only one adjustment for resistance on this, and that's on the, I think, the 2K range. The others depend on the accuracy of the other settings and the resistors, I guess, internally. Well, whatever, because it has a little voltage divider or something, or a current source in it, and measures voltage. Not sure exactly how it works internally. But R3 adjusts the resistance on the 200 ohm and 2K ohm range. As we saw on the 200 ohm range, with this, it was like spot on. So I think we're probably don't need to adjust R5. Okay, here I am on 1 meg. This is a 1 meg, 0.05%, and it's showing pretty much spot on, bouncing between 9999 and 10000 on this meter, and we'll go up to the Tektronix and see what it thinks of it. 1 meg, come on. Oh, so sad. 999, 9994. Well, this showed closer than this, but we don't know exactly what that value is. Okay, and just for fun, I have the 100K. So we'll go on the 200K ohm range, set that on there, and it helps if it makes good contact with the leads, with the probes. 99854, okay? $9,989. Yeah, close enough. Right, so that's all I can do unless I want to get dangerous and check line voltage, because I have this here. And I can go back to AC volts. Let me go with this one. It's AC volts. And I'm going to assume it is a stable output, because I will be switching between the two again. 122 point, yeah, real stable. 122, about 122.2, 122.3. Okay. Switch over here. AC 200 volts. What? Hello? Why is it saying 18? AC. Oh. Let's try it on volts, man. I don't know if I blew it up. 122 point, yeah, 23. Okay, so again, pretty good match. I'm calling that good enough. I made some minor adjustments. It was pretty close to in-spec, as I thought it was. But with nothing better to do, I thought I would run it through all of its paces and get it sort of as close as I can, just because I like it that way.